Let's solve this equation for x. Note that the first thing we should notice is that our bases are matching. We have e raised to x squared minus 2x, and we have that's equal to e raised to the 8th. Since this is the case, we have matching bases, and we have them equal to each other. We can just set our powers equal to each other. That's going to be x squared minus 2x is equal to 8. At this point, we just have to solve this quadratic function. Recognize then that we have quadratic, so we can move our 8 over. This is then x squared minus 2x minus 8 is equal to 0. At this point, we can try to factor. That is, look for two numbers that multiply together to give us 8, or negative 8, but sum together to be negative 2. Those are negative 4 and positive 2. So this factors as x minus 4 times x plus 2. Confirm that that's the correct factorization. 2 times negative 4 is negative 8, and then negative 4 plus 2 is negative 2. So we're perfectly fine here. Then using the zero product property, we get that x minus 4 is equal to 0, or x plus 2 is equal to 0. That is, add 4 to both sides. X is equal to 4. Subtract 2 from both sides. X is equal to negative 2. At this point, we could check our solutions, but I claim that they are x is equal to 4 and negative 2. We want to find the derivative for each one of these functions. First, I want to say, remember that if we're trying to find the derivative of our exponential e raised to some function of x, then via the definition of the derivative of e and via our definition of the exponential function e to the x and chain rule, we get that this is e raised to that function times the derivative of the function. Then I'm going to say that as often as you can, simplify things. So let's start here. Given that y is equal to 2x plus 4 minus 5 times e to the x over 4, first thing I think I want to do is I want to simplify this. This is the same thing as 2 times x over 4 plus 4 over 4 minus 5 times e to the x over 4, which is the same as x over 2 plus 1 minus 5/4 times e to the x. At this point, if I want to find the derivative of y prime is going to give me, well, what's the derivative of x over 2? That's just going to be 1/2. The derivative of 1 is 0, and the derivative of negative 5/4 times e to the x is just going to be negative 5/4 e to the x. Remember that the derivative of e to the x is e to the x. And so that's our derivative. This one I want to rewrite as e to the x plus 1. Remember that a square root is the same thing as a 1/2 power. So here we're going to have the chain rule. So when I find y prime here, that's going to be, via the chain rule, 1/2 times the inner function unchanged, e to the x plus 1, raised to the negative 1/2 power, because that's 1/2 minus 1, times the derivative of the inner function, but the derivative of e to the x is e to the x, and the derivative of 1 is 0. Finding the derivative of e to the 4x squared minus x. Once again, note that this is chain rule. This is the inner function. 4x squared minus x is the inner function. And so, finding f prime of x, this is e raised to the 4x squared minus x times the derivative of the inner function, which is 4x squared minus x. So that's going to be 4 times 2 times x raised to the 2 minus 1, or 1, minus the derivative of x is 1. And so that's our derivative. I'll clean it up just a little. This is e to the 4x squared minus x times 8x minus 1. Here, to find this derivative, we have f prime of t. Well, that's going to be 4 times e raised to the 0.05 times t times the derivative of the inner function, but it's 0.05 times t. The derivative of 0.05 times t is 0.05. And then minus the derivative of 23 times e to the 0.01 times t. That's going to be 23 times e to the 0.01 t, all times the derivative of the inner function, which is just going to be 0.01. Then I'm going to clean this up just a little bit. 4 times 0.05 is 0.2. So this is 0.2 times e to the 0.05 t minus 23 times 0.01 is going to give me 0.23 times e to the 0.01 t. And so there is our derivative. This last one, the first thing that I'm going to do is I'm going to simplify this as much as I can. And so raising a power to a power, or as this is written, this is going to be e to the 3x to the 5th power, or 5 times 3x, which is e to the 15x. Then, if we want to find that derivative, f prime of x is going to be equal to e to the 15 times x times the derivative of the inner function, but the derivative of 15x is 15, so just rearrange, that's 15e to the 15x. So for this one, we want to find the values of x at which the function has a possible relative maximum or minimum. Remember, these things are the critical values, right? Well, then we want to use the second derivative to determine the nature of the function at these points, or specifically, we're asking the question, otherwise they're stating, use the first derivative and the second derivative tests to find maximums and minimums in addition to the critical values. So let's do exactly that. Now, remember that this is a quotient rule, but if you would rather, you could rewrite this as a product rule. That would be 3 minus 4 times x times e to the 2x raised to the negative first power. And so you could, if you so desired, work with this instead and use the product rule if you would prefer. But I'm going to use the quotient rule since that's how it started. So since that's the case, I don't need any of this. And to find f prime of x, that's going to be first we leave the denominator alone, e to the 2x times the derivative of the numerator, but the derivative of 3 minus 4x is negative 4, minus, leave the numerator alone, that's going to be 3 minus 4x, times the derivative of e to the 2x, but the derivative of e to the 2x is going to be e to the 2x times the derivative of the inner function 2x, which is just 2. All divided by e to the 2x raised to the second power. Right? I just used the quotient rule with the chain rules that existed within. Now, I do want to clean this up a little bit because it'll make my life a little easier. And so I see that I can factor out this e to the 2x in the numerator. And so if I do that, that's going to be e to the 2x times negative 4 minus 3 minus 4x times 2 all over e to the 2x squared. Now the nice thing here is a few things happen. I can see that e to the 2x divided by e to the 2x squared, there's an e to the 2x and an e to the 2x that divide by each other and give us a 1. And so then I am going to be left with just e to the 2x in the denominator. Now the numerator, I'm going to have to deal with it a little bit, but notice that that 2 can be distributed, and if you want, you can deal with this negative and the 2. And so that's going to be negative 4 minus 6 plus 8x. And then this is going to be equal to negative 10 plus 8x over e to the 2x. Now at this point, the first thing we're supposed to do is find the critical values. And so remember that to find critical values, you set the first derivative equal to 0, and so this is negative 10 plus 8x over e to the 2x is equal to 0. We do have something related to a rational expression here, and so I can just multiply both sides by the least common denominator. That's going to be e to the 2x, e to the 2x. e to the 2x divided by e to the 2x is 1, and I'm going to be left with negative 10 plus 8x is equal to, well, e to the 2x times 0 is still 0. I can add 10 to both sides. 8x is equal to 10. And then I've got, divide both sides by 8, x is equal to 5/4. And so my claim is that this is my critical value. That is the possible location of extrema. from our original function. Well then, since we found the critical value, the next part for us to deal with is we need to figure out, is that critical value a max, min, or neither? And so remember that now we can take the second derivative, and so let's make sure we see that this was our first derivative. Then I can use the quotient rule again to find f double prime. And so f double prime, that's going to give me e to the 2x times 8 minus negative 10 plus 8x times the derivative of e to the 2x, but that's e to the 2x times 2, all over e to the 2x quantity squared. But then e to the 2x will factor out again, so that's e to the 2x times 8 minus 2 times negative 10 plus 8x, all over e to the 2x quantity squared. But for simplicity, the e to the 2x divided by one of the e to the 2x's in the denominator is 1, and then in the numerator I'm going to be left with 8 plus 20 minus 16x, all over e to the 2x. At this point, I just want to calculate what is f double prime of 5/4. And so that is 28 minus 16 times 5/4, all divided by e to the 2 times 5/4. I get that this is approximately 0.66, but what matters here is that that is strictly greater than 0. And since it's positive, I know that I have a concave up function, and if it's a concave up function at that value, then we know that it is a minimum. And so now I know that our critical value, x equal to 5/4, is at least a relative min. We're told that the value of a computer t years after purchase is modeled by the function v of t, standing for value based on time, is equal to 2,000 times e to the negative 0.35t dollars. And so they ask us a question, that is, at what rate is the computer's value falling after 3 years? And so specifically, the rate at which the value is changing is the question being asked. Therefore, we're trying to find v prime of t, but we're not going to use t, we're going to use 3 because that's the specific value that we want. First thing we need to do is find our first derivative. So v prime of t is equal to 2,000 times e to the negative 0.35t times the derivative of the inner function, negative 0.35 times t, which is negative 0.35. But then 2,000 times negative 0.35, that's going to simplify to be negative 700 times e to the negative 0.35t. Now we can just plug in our 3, so v prime of 3 is negative 700 times e to the negative 0.35 times 3. I get this is approximately negative 244.96 rounded, and I rounded to a penny because we're talking about money. And so I claim that after 3 years it is depreciating in value by $244.96 per year.